All right, thanks, Bill. I'm here with Justin as well. We're going to get started with today's webinar. One of the things that I'm really excited about with this webinar, we put a lot of things into every release. So you'll see the dot releases that come out, 17.1, 17.2, and we try to keep them as action-packed as possible. So if we missed anything from those releases, I hope you've kind of caught up from that time and you've seen all the improvements we've added. And also I want to note that with this release, 18 has been out for a little while now. You've probably seen little hints here and there of what we've added for the geometry tools and capabilities that are here. But I'm glad everyone has attended so we can focus on a lot of the geometry and get down to it. Anything to add, Justin?
Nope.
Great. So to go over, we're going to go over a bunch of different things. Again, we've tried to group these into categories that make a little bit of sense. So we've added a lot into modeling, just the core modeling of what makes SpaceClaim really useful across all areas of physics. In addition to that, some new visualization, and we'll demonstrate that at the end of today's presentation with a fly-through. We've added one of our top requests for small units modeling. We'll get into that in a little bit as well. And then we've kind of broken it up into typical things that we add, like interop, new translators we're supporting, new things that you've seen constantly being added with scripting, give you an update of kind of the new improvements we've made there, and also some overall enhancements to the different CAA workflows that we know you guys are a part of. So with that, I think we'll go ahead and jump right into this. So with our modeling capabilities that we've added, again, we always try to go back, and you don't see all of the fixes that we put in, all the small tweaks and details. And if you go and look at the release notes, Justin, I forget how many there are, but I think there's over 100 pages of like new functionality that's been added in every single year of release that we put in. So we're just calling out a few of the key improvements that we've added. And one of the neat things we've added here that we're kind of showing, probably not the best model to show for a volumetric sweep, but I think the holes kind of let you see it a little bit better. But what we've allowed you to do now is to actually sweep a volume along a path. So if you have a component that's going to be having some movement applied to it inside of an assembly, you can actually sweep that entire solid along a path, and then you can check to see if there's interference with the model. You can skin and recreate that as a solid geometry that's there at the end of the day if you want to include something like that in your simulation. Because what's kind of interesting about this is it actually took some proving to me. I had Silvergel over the shoulder and proved to me that there is a difference between sweeping a face and sweeping an entire solid body. But you do truly get a different result. I mean, you see it a lot in manufacturing if you're sweeping like an actual cutter to make a tool path that's there. So there's a lot of cool things you can start to do with this type of geometry manipulation. In addition to this, you'll notice that if you use our blending or lofting capabilities, you look in the bottom left-hand corner, we've tried to improve this and make it a lot cleaner and easier to see. So we've added some of the new capabilities that we've added to equations. And if maybe you missed it, but in the 17 dot releases, we added the ability to input equations. And we added some of those graphics to the blending to make it a lot easier to see what's going to be created. And last but not least, and we'll show this at the end of the demonstration, is what I see and what we see more and more in the engineering world is people doing reverse engineering, basically recreating solid geometry over a faceted body. And that could be from scanning, it could be from topology optimization, but a lot of times people want to recreate that data and basically see the differences between them. What we've added now in this release is the ability to go through and actually see the difference between two models. So you can actually create just a small surface on the geometry and actually see the deviation between them. So as you're starting to create or recreate some geometry over the STL, you can intermittently see how close you are instead of kind of waiting to the very end to apply and see the difference between the whole model.
So Roman, one thing if I can jump in here, a lot of people overlook this side of SpaceClaim, the fact that it is a really powerful modeling tool. The ability to clean up models, repair geometry, and take an original CAD model and make it ready for simulation is a great use case for SpaceClaim. But I just want to remind everyone that if you also want to create a new design, model an idea that you have in your head, or more importantly, changes to a design, don't forget that we're always working to improve SpaceClaim and allow it to model more things more quickly than ever before.
And one of the reasons we do that is the better the core modeling is, everything you do for any prep work for simulation will become easier. All your fills will become easier, pulls, moves, all of those functions will improve. And one of the things we always try to do with our development team is we always try to kind of work quickly and work efficiently and get results. So here you'll see we have the ability to unfold surfaces. One of the things you might not know about this, though, is that in the past, I think it was maybe 2 releases ago, one of the big enhancements in the electronics world, people that were using HFSS, was actually take antennas, flexible circuit boards, and wrap them onto something. And so with that ability, I mean, it was pretty tricky to figure out how exactly we would wrap this geometry onto complex, doubly curved surfaces. We solved that problem. We figured out all the little challenges that came up. But then we said, well, if we're able to wrap things onto it, we should also be able to unwrap. So if you get a doubly curved model, you should be able to unwrap that into its flattened state that's there. That's basically what we're doing here is we're taking surface geometry. Notice this is a little stamped part. We're actually letting you select on that and unroll that and flatten it back into its flat state. And we really try to minimize the stretch on the area of the geometry, but also the length of edges that are there. So try to keep them as close as possible to the original shape that's there. And I think we'll demonstrate this at the end of the presentation as well. But one of the key things I like to try to mention with this is that if there's areas we develop that might be useful, we always try to make the best use of our development time and expand that into other areas. One of the neat things we've added here, and it's kind of hard to capture exactly what fly-through does in just a single image, so I will definitely be showing this at the end of the presentation, how we can get into fly-through and how we can visualize things. But it really helps you see inside things. So when you have, again, complex models, hiding bodies is one way to do it. You can make bodies transparent. You can go into cross-sections, and we have great editing tools in a cross-section. It's one of the unique differentiators of SpaceClaim is that any change you make in a cross-section, exact same thing as making that change in 3D. But with this, you are actually inside the model. So beginning to a perspective view and seeing it. And, you know, I'll stop talking about it now because it's not going to do it justice. So we'll definitely show this at the end. But it makes it a ton easier to see inside your parts and inside your complex assemblies. One of the other interesting things we've done here, and Justin works a ton with some of our topology optimization engineers and topology optimization product managers, we're adding a ton in STL manipulation and also lattice creation to support additive manufacturing. Justin, do you want to touch on a little bit of this?
Sure. You know, in general, again, another overlooked feature of SpaceClaim is the fact that we work with not just full CAD geometry, but also faceted data. This is typically STL, OBJ formats that you guys are probably familiar with and have come across in the course of working with geometry. You can clean up geometry, modify even these faceted formats as if they were the original CAD file that they probably came from. Now, as Roman said, we're always looking to extend the capabilities to make sure that we can either model and clean up things that maybe we weren't aware of before, new types of problems. In this release of SpaceClaim, we did really cool stuff with generating what we call lattice structures. The purpose for these is usually to lightweight a part. And if you think about it, you can take a part, like if you look at the purplish part on the top right, you can take something that might be solid like the left, the bracket, and you can use SpaceClaim to generate the fairly dense and complex internal lattice structure from one of the shapes shown at the top. So there's a lot of different types of patterns, and we call these lattice because generally they consist of multiple thin members that are attached at various points. The reason that people like to use lattices is because they tend to have really great strength to weight ratio. They're very stiff for the relatively small amount of material that they contain. Now, the reason that people do not love to use these is they tend to be really, really difficult to manufacture with traditional manufacturing methods. What's great is, especially in the world of faceted models, we're often talking about using additive manufacturing to make them, which means that lattices like these can often be a really good design option in making a strong but lightweight part. And also here, again, some things with stuff that we'll continue to work on going into the future, so stay tuned.
Right. And one of the things we're adding right now with kind of topology optimization, additive manufacturing, is a great link inside of Workbench to basically get the geometry directly from the topology optimization that's being done in mechanical and directly into SpaceClaim. And so once here, you can either recreate the geometry that's there based on the type of manufacturing you might be doing, because topology optimization is also useful even with traditional manufacturing, whether you're machining, casting. You do a lot more with additive, but it still is awesome for traditional manufacturing. It lets you take and recreate the geometry in SpaceClaim and basically link that back to a validation run inside Workbench. Because again, it's important that when you're creating the geometry, when you're doing a topology optimization result, they actually make sure that the final model that you will be using kind of passes whatever requirements you might have. And so with that, we're going to talk about the data interoperability a little bit. So one of the things we've added, I mean, we always try to support the newer versions every release. And with the dot releases, it makes it really nice because we can integrate new versions of software as quickly as we can get our hands on them. One of the things we added is the ability to import STEP. It's a new version of STEP. Well, it's not new at this point, but 242. And one of the things that we do with this is we import PMI, or the GD&T that might be on a STEP file. So we'll bring that into the model. And in addition to that, we'll bring in IcePack and Fluent files of TGF and .tin, so you can bring that right into SpaceClaim if you have old versions or old files that you want to bring in and edit or modify. And also we're able to export TGF files as well. And you'll notice if you actually go into the SpaceClaim options for TGF, you have the similar controls that you might have with STL or OBJ files.
In general, our goal here is to make SpaceClaim integrate and work as nicely with all the products in the ANSYS portfolio. So that's why you see us adding a lot of these formats.
And one of the other things we added, which people might not be aware of, this is a feature that we've actually had in SpaceClaim from almost the beginning, a batch converter. But basically, it's inside of the install folder. So typically, that would be C, program files, ANSYS, whichever version you have. This is 18. So ANSYS 18 SCDM. Inside that folder, there's going to be a converter.exe file. And what that will actually let you do is it'll let you specify a group of parts, 5, 10, 100. You can pick files that just contain parts. And you can basically have that session run and just open that file and save it as a SpaceClaim file. Or even open a Parasolid file and save it to STEP. So it's a great way to batch convert a lot of data that's there. And one of the things that we added in this release to that is if you're coursing through a ton of different data that's there, if you have a lot of big models, you can actually have it start a new version of SpaceClaim for each design. And it's just a more robust way to open that, because if you're opening up, I don't know, 50 models that are all 500 megabytes or pretty big models that are there and you're running overnight, it's just a more robust way to do that and to make sure everything's going to open and you're not going to run out of memory that's there. But if you do open and work with a lot of large data files, I would definitely suggest checking out that batch converter. All right, so one of the other things just to go with the TGF files that I was mentioning in the last slide, new workflows for Fluent meshing. So you can actually take these TGF files, as faceted data export options, directly to Fluent. So it's going to create the TGF file and you can bring that directly into Fluent, and you actually retain different objects, regions, labels. You can make these in SpaceClaim with name selections before saving that file. Oh.
The important thing, to note here is that the structure comes across to a certain extent, right? The assembly structure that you see in SpaceClaim and that might come from your original CAD file, we're preserving these part names and a lot of the groupings, which is really useful when trying to assign boundary conditions and things like that in simulation.
Yeah, so instead of having a group of things that are just unknown, whatever you call them here will be called them there. And one of the other things, though, I'm definitely a novice at scripting. I'm able to record some functions, learn it. I'm trying to get a little better at it, but Justin is a scripting guru. He can make this scripting dance and sing and do anything you want it to do. So I'm going to turn this slide over to Justin to talk about some of the new things he's added in this release.
Roman's too humble because you might have seen the blog they recently wrote on SpaceClaim scripting. So he's certainly becoming better than novice, which is what I think any of you could do if you start to look into it. So scripting is something we've been working on for the last year in SpaceClaim. And the reason is because we think it's really powerful. It allows you to automate tasks and customize SpaceClaim for whatever it is that you might need to do. This could be cleanup, this could be modeling new geometry, this could be creating fully parametric models. And again, we'll do entire webinars, we'll talk about this more, but what I would recommend to all of you is now that we've worked on this for a year, I highly suggest you check out scripting. And the best place to check it out, and maybe Roman will show a little bit of this during the demonstration, is right within SpaceClaim. There's nothing extra you have to install. You can just create a new script and hit the magical red button that you might see on this slide at the top of the editor, which will record. And what you see on the right is an example of automatically recorded and generated script. So while that's on, if you start modeling inside of SpaceClaim, the script will automatically record and generate text, which is what a script is, that will replay your modeling operation. So again, you can think of what to do that. You can then edit that text, put it in loops. Again, it's really, really powerful. One of the elements, if you have tried scripting and you want to know what we've added in this release, is we've added something that we're calling smart variables. All right, a key element of a script, and Roman's highlighting right there, smart variables in purple, you see it right there. The key element of a script is how it targets things. When you want to run a command, how does it figure what to run it on, what objects to run it on? Okay, and we had multiple different approaches you could take. You can reference the ID for a face or a body. You can reference its order in the assembly, like this is the 5th body. Or you can actually try to look at exactly its shape, its type, characteristics of it. We captured all of those things inside of what we call a smart variable. That's what makes up the smarts part. And in a script, it just appears as this, magenta colored item, which is holding all of that magic inside there. The reason this is great is because if you record a script using these smart variables, it tends to replay really, really robustly. And that's all you really have to care about that. Now, something else, a couple of things to highlight. We've done some work to clean up and allow you to execute these SpaceClaim scripts that you may have written from Workbench. So if you're trying to script an overall workflow that involves creating geometry, maybe passing values to it, and then sending that geometry to simulation, you can now do that from inside of the Workbench scripting environment, which is pretty cool. We, of course, also added coverage, so there's more and more tools in SpaceClaim that are now scriptable and also recordable. And finally, a really great customer request that came in was, in order to help you write and learn about scripting, we include embedded in the scripting environment examples and what we call snippets. They're snippets of essentially script text that show you how to do things. They could be how to grab a selection, how to create a loop. Again, really, really cool feature that probably most people don't realize. But what customers asked us for was the ability to provide their own snippets that users can then quickly access and use. And that's an example of something that we put in the software at R18. So again, I encourage you all to check out scripting. We have some content available to learn about it, as well as a bunch of documentation inside the SpaceClaim install.
Cool. And going into some more of what I think a lot of people tuned in for, some of the directly applicable CAE enhancements that we've added. One of the big enhancements that we added in this release is the ability to exclude from physics. And so in the past, prior to version 18, it was a simple rule. things that are visible get transferred, things that are not visible do not. But a lot of times people want it to be able to see what's in their assembly, see what's in their design, but still not have a few things transfer. So they want us to suppress them in the graphic, in the geometry interface. So what we've added in this release is the ability to right-click from the design window, right-click from the structure tree, and essentially exclude from physics. That's there. And so what will happen is you'll notice you'll get a little icon on your geometry inside of the structure tree, and anything with this icon on it will not be transferred into Workbench. So you can still have things visible, but not have them be transferred. Now, a key thing with this that you probably have noticed by now is that old documents, anything that was created in version 17, 17.1, 17.2, or earlier, if things were hidden in those files, they will come in as suppressed bodies. So if you want to remove all those, you can select everything in the structure tree and toggle them on and off to remove them. But generally, the idea was that hidden things were suppressed in the past, so hidden things should be suppressed moving forward. The other things we've added with this is a new IcePack Level 3 simplification. So if you're using IcePack and you're using some of the tools in the electronics toolkit from Design Modeler, a lot of those tools have been added into SpaceClaim. We've added a lot of enhancements to beams, performance gains. We're constantly trying to make those as quick as possible. And the reason is because a lot of times when you're using beams or shell modeling, you're working with not tens of parts, but thousands and thousands of parts. So doing these in performance gains really help boost the speed of transfer and working with the geometry in both Workbench and SpaceClaim. And one of the other kind of big ticket items that we've added in this release, which is again a top request, is small units modeling. So for people that are doing again, piezoelectrics, like really small things, you can now work in nanometers or you can now work in micrometers. And basically, I'll show this really quickly once we get into the session, how to set that up. But it's just a new unit setting. Once you set it to micrometers, it's set to that, and new sessions will open up in micrometers, and it'll pass geometry back and forth between Workbench, no problem. Do you have anything to add, Justin, that I might have missed with the...
No, with the small units modeling, we do also support this when reading in and out file types that support units information. So if you have, say, a step file that's defined as units as nanometers, that will also be respected, which is pretty useful.
All right. So some of the other things with this being a geometry update that we've added. So publishing of read-only design parameters. This is some design modeler enhancement that we've added. A few other things we've added is name selections are being exported for Blade Editor as going through. And that similar workflow for topology optimization that we added for SpaceClaim is also supported with Design Modeler as well.
Yeah, the important thing to note here is we do continue to do some work to improve Design Modeler. As you can quite obviously see, it's not nearly the amount of scope of effort that we spend in improving SpaceClaim, because that is generally our recommended tool going forward. But Design Modeler is currently still a useful tool in the ANSYS geometry toolbox.
And so just to close this out with a few detailing enhancements, I think Justin kind of mentioned this at the beginning, but you can use SpaceClaim for a core modeling tool, and you can use it more than just for simulation prep with filling holes and editing rounds and things like that prior to simulation. So just to make it a little bit easier, if you want to put on dimensions or detailing, we've added limits and fits. So we have a full drawing package, but we added limits and fits to that. So you can just call out common tolerances that you might be using. And we'll skip the other detailing. But we've added a few kind of tiny little enhancements to make it a little bit easier to make and create notes and kind of assemble them onto your drawing sheet. So with that, though, I'm going to go ahead and get into the demonstration. And I do see a lot of people typing questions in. Definitely, Justin's answering a few of them as we're going through. But if you want to, you can definitely feel free to ask more questions, and we'll try to get to all of them at the end of the presentation. So a few things with the software that's going through. I want to point out a few things that we added just for people that are unfamiliar where they might be located. But if you do want to add small units or change your units to support small units, it's simply under units, and you can set the size for new documents to be imperial or metric, or start supporting nanometers or micrometers. So setting that here will let all new sessions be started in these units if you're working on small things. That's the best place to go for that. The other thing that I wanted to point out, again, for people that might have missed it, but if I start to select on one thing, and if I want to go through and start to find all things that are small, or maybe I want to get just all really tiny things in the model, and I do not want to include these in my physics, right-click, suppress for physics. What that's going to do is it's going to keep them visible in the model, but if I locate this in the structure tree, you'll notice there's going to be a little icon next to these components, and these will not be getting transferred into Workbench. This will not. So if you want to be able to turn things off prior to running your analysis, that's a great way to do so. The other thing I wanted to point out with this is right now, again, if I just zoom into something, you'll notice as I zoom in, it just zooms in ever closer to that thing, right? I'm always going to see the white and the blue faces on the top of my model, my screen. So I'm never going to zoom in further than that. Fly-through is a really interesting new capability that we added. And one of the things that's helpful to get started is under display, we have a new camera options that are there. And that will actually add camera options underneath your regular options panel that's there. And the interesting thing with this is that you can switch to perspective mode and fly through, and that's all you need to do to be able to zoom into your part. And the other thing that's nice with this is it does support the use of a 3D mouse. So if you are using a 3D mouse to zoom into things and zoom around and kind of see what's going on, this is a good way to see this. But once you're inside the model, just to note, I am now inside my model, inside my design. And so I can start to look around and see the insides of this part to work on it. You might notice key things that you might want to change or tweak or modify. And once we're inside this zoomed up place, you can start to make and change and modify the geometry. So it would have been very difficult to start to see inside this part, inside this model. But this makes it really easy to get into this type of position in your design. And one of the things that is also helpful as a shortcut, if you want to rotate around your camera, holding the Alt key down lets you keep the camera position where it is and just look back and forth to see what's going on.
Again, one place that we really thought users would want to use this the most, and actually what they've asked us to use it for, is when doing any sort of architectural building type modeling. In that case, SpaceClaim, again, historically only lets you look at things from the outside. Being able to change the way you view your scene is pretty cool and gives you another way to work.
And this is even, right now, I am literally inside the middle of a solid body. And so you notice the inside will be slightly pinkish, versus the outside being a different color.
And one other thing to point out, we get a lot, people who are doing fluid simulation, and they want to make sure they go inside and tag stuff, maybe name selections. Fly-through might be a really great tool if that's your workflow, trying to look inside of a volume and make sure that you label all the faces.
And once you're done, just simply go back to orthographic and turn off fly-through, and now we're in our normal spin, pan, zooming mode. It's there. And as a quick, just a nice tip, you can always customize your navigation in SpaceClaim by going to the File menu, Navigation. So while here, I mean, you might be going into a fly-through mode. And actually, I opened up one of the small parts or sub-assemblies inside the design. And so one of the things I just wanted to point out and show quick, like if I hide others here, inside our Prepare tab, we have kind of started to add a lot of the ice pack simplification and abilities that are here in the design. So one thing we can do in this design scenario is in the past we had level 0, 1, and 2 simplification. And again, level 2 is nice because this is actually one single body that's there as it's going through. Level 2 will actually break this up into different sections based on the geometry that's on the design. And level 3, what we've added is the ability to treat this as a single CAD object. And you can control the facet quality that it will use as it does the simplification, but it will create a single body for this at the end of the day. So for people using IcePack, again, we're trying to add a lot of these workflows that you have been supporting and using in the past. So definitely feel free to give us feedback on this, or if there's other things that you want or you'd like added, definitely let us know. To go to some of the other features that we kind of talked about as well, one of the things I wanted to point out was the ability to use unroll that's there. And I actually had a few questions that came in about wrapping and can we wrap 2D or 3D. And so in the past, under this Insert tab, we added the ability to wrap. This will wrap 2D objects onto geometry, and it will also wrap 3D objects that are basically 2D extrusions. So you have like a long, thin rectangle, that's something you could wrap onto something. But you couldn't wrap something like a sphere onto a cylinder. It would have to be like 2D extrusions. But with something like this, the opposite of that is going to essentially be unroll, taking surface bodies and kind of creating the flat body for that. So I've actually already, I'm going to hide some of the other components. I've actually already created the mid-surface from this body. So I've created a mid-surface for the design here. And what we're going to do is unroll it. It's probably the easiest tool to use. Click wherever you want the unroll to start, and unroll will create that flat surface from it. This is where I love easy tools. But it's going to create this unflattened surface that's there in the model. And some of the key things I'm going to point out with this, if I go to measure some of the details of these surfaces, so the length of that edge is 57.9. This is 56.5. We're trying to keep the edges very close to the same amount and the same size. And also, obviously, there will be some stretch involved with this, but the area of, I'll just switch this to inches, the area of 50.68 inches versus 50.63 inches, it's a very close. So we're trying to keep the area, and we're also trying to keep the edge lengths as close as possible to limit the stretch that's going to occur. And all the small details you see in one, you'll notice also appear in the other.
And just to be clear, you can't flatten something unless it's wrapped in a very basic surface, what's called primitive surface types, things like cylinders and perhaps things like cones. But when you get a part like this, when it was actually manufactured, it absolutely deforms. So flattening is always going to be a least deformation problem. That's how we tackle it. You will never get exactly the same length because mathematically it's absolutely impossible.
I always like to think of it like putting a sticker. Like you can put a sticker on a Coke can or on a cylinder, but if you try to put it on a sphere, if it's a tiny sticker on a sphere, it's going to be fine. But the bigger the sticker is in relationship to the sphere, you're going to get little crimping, you're going to get little stretching that needs to happen or rips that need to happen in order to have it be perfectly flat.
Exactly.
And because I use stickers all the time. So. All right, so one of the last things I want to point out is related to facets as we go through. And again, we're trying to add a lot with facets because, I mean, one of the core beliefs with SpaceClaim is you as a user shouldn't have to worry if you're working on a step file versus a SOLIDWORKS file versus a Creo file or an IIOT file, or kind of working to be able to work with STL files in the same form and fashion. So we're doing a lot more with STL files. And one of the things we've added in this release, as Justin was mentioning, is the ability to go through and actually add lattice structures within parts. So if I go to shell this out, you'll notice that if I go to shell this, I can give it a thickness, I can change some parameters, or I can provide an infill as I do this. Now, in the past, we did have a few of these infill options available, we've added a lot more to support a lot of the different truss structures you might want on the internal of your part. And it's sometimes hard to see some of these icons, so I always suggest that to see it a little bit better, hover over it, preview, get a good idea of what that's going to look like within your part. But if we also want to see what this looks like, we can actually create our own infill on this model. And one of the other things we've added, which is unique in this release, is we don't assume what values are going to be there. Based on what you select on your model, it automatically sizes a length and a thickness that it thinks is a generally appropriate size for your model that you select on. So instead of having things be wildly too large or small to start with, it will auto-size to get you a rough approximation. But as with anything, obviously if you want to change the size or the shape of any of these values, you can obviously type your own in. One thing I think is really helpful with this as well is that you can actually see the offset going through, so you can see what that might look like in various cross-sections. And normally this would be a lot finer. We would have a lot more facets. I'm kind of making this fairly coarse just to show you what this would look like. But one of the other things I wanted to add with this as we're going through is add the ability for you to see the inside of this. So instead of just making an infill in this solid part, I'm actually going to basically shell and remove faces from this model. So here we'll remove faces from the design. I'll remove some of the interior, and we're going to go ahead and create this. And Justin has been working, again, a ton with people doing additive. We have a whole team here looking at additive and how it's going to affect the future of manufacturing. And we're really trying to get ahead as much as we can on the needs of our customers and what we may be looking for in the future. So here we can see what that looks like. And again, you can see what it looks like a little bit better because I removed those faces. But it creates that faceted form and that faceted interior all throughout the inside of the part. And just so you can see this a little bit better, if I go into a cross-section, this is what the internal looks like. The shell I gave it on the outside, it maintains that outside thickness, and everywhere else it has that faceted design going through the part. So this would be, I mean, essentially impossible to manufacture something like this with the traditional method. With additive, again, you reduce a ton of the weight, but keep a lot of the strength by applying and having these faceted interiors.
Now, Roman removed those faces, showing something that you can do here with the tool. He did it in a very large area, really to add visualization, but this is really useful sometimes for adding areas where you might need support material or powder that might be as part of your printing process to come out. So that's a case of why this is a useful feature.
And although I showed this on a faceted body, the same technique, the same process will work on solid bodies as well. And this might be, you might not even be doing much with additive yourself, but a lot of times different departments or different companies will have departments that are focusing on additive. So if people are looking to do this type of work, I would definitely let them know about some of the capabilities that have been added. Now, one of the last things I wanted to point out and show, so instead of having this kind of mostly deformed bone with the interior missing, I'm going to go back and bring up the original one. Because one of the neat things we added, again, we've had skinning for a few releases now in order to create surfaces onto complex shapes, like organic doubly curved shapes that are there. So I'm going to go ahead and add a new skin surface in between these two planes. Because one of the unique things we added, again, you can control the samples, you can do a preview. What this is going to be doing is creating a surface in between these two planes. But one of the unique things we added in this release was the ability to compare just a single face or a surface body to the actual faceted model. Because in the past, we've required you to create the whole body, which, and sometimes the more complex the model is, the longer that takes and the less reasonable that is. But now we can do a deviation or a check between just that faceted or just that surface body and basically compare the surface body to the faceted body. And first you'll notice it takes, I mean, half a second. I'm not sure if that even took a full second to produce this check or this deviation. What you also notice is it shows you a lot of the areas in red and blue where it's off. But just to highlight, this is the size that is off. the maximum inside is 0.07 millimeters, and the outside is 0.1 millimeters.
How can it possibly be so close, Roman?
Well, it's using a ton of sample points as it's going through. So it's essentially using 50 sample points, and it's comparing that and laying that onto the model. And Justin has done some pretty interesting work. We essentially basically unwrapping the STL and comparing the points that are on that flat part, mapping that to a surface, and then rewrapping that on the body. So it's a lot of complex algorithms that are going behind the scenes to make it as close as possible to this design. And what shows us a little bit better is this tolerance. You might have a tolerance of 0.05 millimeters. Like, that's crazy tiny. But you can see how close we actually are to that surface. And in the event that something is off or you might want to tweak or change something, you could go back in and literally control the tweak face, these curvature, these points on the surface to tweak this. If you actually had a section that was off by a lot, you wanted to tweak the location of any of these points or corners that are there. But in reality, the skin surface works really well to change, and so not to change, but to create a new surface over the STL that I rarely have to do any editing after I create a surface.
So you'll notice that a lot of the things that Roman showed you today and that you see we're working all fall under the same topic of allowing you to do more with faceted data. A lot of people think of these as dead formats. Thanks to SpaceClaim, you can either edit them directly or reverse engineer them into full CAD models with full surface data that you can then use manufacturing, simulation, or anywhere that you might want to have geometry.